Okay, so you should recognize these because we've been talking about these for a while. Okay, but if the function is in vertex form, describe how each of the following variables affects the graph. Okay, so we're going to use some mathy words here, but we're going to make sure that we understand what they mean also. Okay, so the A is responsible for three things. Okay, if the A, we'll talk about the absolute value of A. All right, so we're not really concerned about the negative. If the absolute value of A is greater than 1, okay, we call it a vertical stretch. Okay, and that's the math phrase for it, but basically it makes it more narrow. I should just put more narrow. Okay, so some teachers are teaching it as more narrow. Some are saying vertical stretch. I know for my kids, I always say vertical stretch. All right, so that's what you're going to see. Now, if A is between 0 and 1, all right, so if we have the absolute value of A is between 0 and 1, okay, and that is absolute value signs around the A, we call that a vertical compression. Okay, vertical, let's see if I can get all that in here. Vertical compression, I'm going to have to abbreviate vertical compression. All right, and ultimately what that means is it's wider. All right, and then the A is responsible for one more thing, okay? If the A is less than 0, which is negative, okay, ultimately if we have a negative A value, then we have a reflection across the x-axis, which means it opens down. So those are all of the things that A is responsible for. I talked a little bit about the possibility of a B value, but that B is not going to be on the test. Okay, so the B that goes right there in front of X right there, it's not going to be on the test. Okay, so how does H change the graph? These should be fairly straightforward. Okay, remember H is responsible for the horizontal translation. Horizontal translation or shift. I think I've used the word shift a lot more than translation. Okay, but that's going to be left or right. It's always opposite sign, okay? Always opposite. Remember, it lies to you. Anything inside lies to you. All right, so if you see a minus, it actually moves it to the right. If you see negative, it actually moves it to the left. Okay, and then the K value is the last one. All right, and then K is pretty straightforward as well. Okay, we call that a vertical translation or a vertical shift, up or down. So that's what those will do. So if I'm given an equation, like in number 17, it says describes the graphical changes. So it says to use words like shifts up or down, left or right, wide or narrow. I'm going to use some of the more mathy words, all right, because that's kind of the way that I've taught it, okay, and I want you guys to be comfortable and familiar with these math words, so I think that's how it's going to be on a state-issued exam, okay? So changes to the graph. First thing is I noticed that negative, all right? I'm going to take a look at that. That's going to cause a reflection across the x-axis. So let's say reflection across x-axis. So the way to kind of like in normal words describe that, we're going to say it opens down. Okay, but we need to recognize it as a reflection as well. Okay, and then what else happens? Well, the 1/3 actually makes it wider. Okay, we call it a vertical compression. So we'll say vertical compression by 1/3. Okay, or you can say wider. All right, and then what else happens? What does that 2 do? Okay, it's inside, so it's responsible for something that's horizontal. Okay, we always look at the opposite. So we're going to say a horizontal shift left 2, because it's opposite of what we think. And then we would say vertical shift down 1. Down 1. Okay, that's what that -1 does. That's kind of how we read those, and that's how we would take a look at the vertex form and get a better idea for what the quadratic looks like.